Hello students, in this video we will learn to solve questions using permutation formula. Okay, so exercise 7.1 and 7.2, you have come across questions like, some questions are asked whether repetition is allowed and some are repetition not allowed. So in case of repetition not allowed, you can use permutation formula. Okay, NPR equal to n factorial divided by n minus r factorial. Okay, this is the formula for permutation, and where n is equal to your total number of objects and your r is number of objects we have to arrange at a time. Now you see question number 1. How many 3-digit numbers can be formed by using the digit 1 to 9 if no digit is repeated? So in exercise 7.1 also you have done the similar type of question. Okay, 3-digit number. So what we used to do is we make 3 boxes. Okay, can be formed by using digit 1 to 9 if no digit is repeated. That means in the first place I will have options from digit 1 to 9. That means I can have 9 numbers, say 1, or I can start with 2, I can start with 3 till 9. Okay, so if digit is not repeated, then here I will have, if I have taken 1 here, then I will be left with 8 digits, 8 options. Okay, 8 numbers will be left with me, and similarly for the third one I will be left with 7 numbers. So from what you used to do in exercise 1 is, from principle of fundamental counting, you multiply all these 3, 9 into 8 into 7. Okay, answer is 504. Okay, now to make it more shorter and more easier, you can use here permutation formula as repetition not allowed. See, no digit is repeated, so repetition not allowed means I can use permutation formula, NPR formula. Okay, now n is your total number of objects. Here objects means in this case it is digit is provided, total number of digits. Okay, it is ranging from 1 to 9. That means you will have 9 digits. Total number of digits, this will become your n. N is equal to your 9. Okay, now your r, number of objects we have to arrange at a time. Now we have to arrange 3-digit number, 3. Okay, so in this case your r will be 3. Now you can put the formula 9p3. Okay, now the formula is, NPR formula is n factorial by n minus r factorial. Okay, so 9 factorial divided by 9 minus 3 factorial. Now you can solve this. Factorial is very easy. 9 factorial, 9 minus 3 will become 6 factorial. Okay, now 9 is lesser than 6, so I can open this and make it 6 factorial. 9 into 8 into 7 into 6 factorial by 6 factorial, and 8 9s are 72 into 7, 7 is 504. You see? So using the same question when digit is not repeated, okay, repetition not allowed question, then we can use the same. From using principle of counting also we can use. Similarly we will use the permutation formula also. If the question is asked that solve the question using permutation formula, then you are going to solve it this way. Okay, if nothing is mentioned, then you can do it from the principle of fundamental counting also. Your answer will be same. Okay, so I hope this question number 1 is clear to you. next is question number 2. How many 4 digits number are there with no digit repeated? Okay, that means we have to form a 4-digit number, but here they did not mention what are the digits. Okay, but we know that for forming a 4-digit number, we have the number from 0 to 9 only. From here only we can construct a 4-digit number. This we know. Okay, numbers are. If they don't give in the question also, this we must know how we construct a 2-digit number or 3-digit number from the number line. We know all this number. Okay, so now forming a 4-digit number, like this, I have made 4 boxes. Okay, now according to your exercise 7.1, how you used to solve is without using permutation formula. First is 4-digit number. Okay, if suppose in the first place you put 0, 1, 2 and 3. Okay, now this 0, 1, 2, 3 will not give you a 4-digit number. It will straightly give you a 3-digit number. So you must be very careful with that. Okay, if it was 1 and here it is 0, okay, then this is a 4-digit number. Or if here it is 0, then this will also give you a 4-digit number. But in the first place, that is your 1000 place, for 4-digit, if you keep 0, then it will behave as a 3-digit number. You must be very clear with that. Now, so for the first place, that is in the 1000 place, okay, I will have 0 I cannot use, so I will have numbers from 1 to 9. That means I can use only 9 numbers. Okay, 9 numbers. Actually from 0 to 9 there are 10 numbers. Okay, but since in the first place we cannot use 0, so I will be left with only 9 numbers. And similarly for the second place, okay, digits cannot be repeated. So if suppose from 1 to 9, okay, in the first place 1 to 9 I have used 9, okay, and in the second place I can use 0 now. So I will be left with numbers from 0 to 8. So I will be left with 9 numbers again here. Okay, 9 ways will be left. Similarly again 1 will be reduced. So here will be 8, here will be 7. Okay, so in exercise 7.1 what you used to do is, in the first place, in the 1000 place can be filled up by 9 ways, like that you used to write. Okay, so I am doing shortcut by principle of fundamental counting. Total number of 4-digit numbers can be formed using 9 into 9 into 8 into 7. Okay, you calculate it that way. 81 into 7 8s are 60. Sorry, it is 56. Okay, when you do multiply of this, you will get 4 5 3 6. Okay, now this is using principle of fundamental counting, but now we must try to use permutation formula. How we can use using permutation formula? Okay, firstly what you can find out is, see, this is your first place, second, third and fourth. How you are going to solve using NPR formula? So what you will do is, see, in this case there is a condition. This is not like question number 1. Okay, here condition is that I cannot use 0 here. So whichever condition is given, okay, you break the box, and for this you can use, I cannot use 0, I will have 9 numbers. From 1 to 9 I will have 9 numbers. That means this is my total object. Okay, for the first place, for this first box, my n will be 9. Okay, and also your arrangement will be I'm considering for the first the 1000 place, that is for one digit, for one box. Okay, so my arrangement will be 1 only. Okay, here my arrangement was 4. Okay, now if I consider all this, then it will be 4, but now I am considering, since here I cannot use 0, so I separated, and for this arrangement n will be 9 and r will be 1. Okay, then for the next one also, what you can do is, the next is, you have 3 boxes. Okay, for these 3 boxes, if you consider 9 digits, 9 numbers you have taken. Okay, suppose if you have taken, say, number 7, then here you will be left with, for the other side, you will be left with again 9 more digits. If you take 7, here I can use 0, so I will be again left with 9 more digits. So in this case my n will be 9. I am considering for the 3 boxes. Arrangement means here my r will be 3. Okay, so now using NPR formula, total 4-digit numbers will be, multiply this, here will be 9p1 into, multiply, and for the rest it will be 9p3. Okay, so you check 9 factorial, 9 minus 1 factorial into 9 factorial and 9 minus 3 factorial. Okay, so you will get 9 factorial by 8 factorial into 9 factorial, 6 factorial. Once you solve the factorial, what you will get, I can express into 8 factorial, 9 into, once I open the 9 factorial, then here 9 into 8 into 7 into 6. I will stop till there so that I can reduce this. So I will be left with 9 into 9 into 8 into 7, which will give me 4, 5, 3, 6. Same thing. Okay. Using this way also I have got the same answer, and using permutation formula also I have done it and I got the same answer. Okay. So whenever you are asked to solve using permutation formula, you are going to do it this way. Or see, okay, again, four digits. Now for the first one I cannot use 0, so I will have 9 digits. So my n was 9 and my r, considering for just one box, r, so it was 9p1. Okay, now again you can do for one box also. Okay, that means in the next also I will have 9 ways. You see here 9, 8, 7. Okay, 9 ways for this box, and if you want to consider for only one box, then for here it will be again 9c1. Here you have 8 ways, here you have 7. So here you have 8p1. For this box it will be 7p1. Now if you solve all this also, you will get the same answer. You try 9p1 into, again for this one, 9p1 into 8p1 into 7p1. Okay, now you check whether you get the same answer or not. 9 factorial, 9 minus 1 will become 8 factorial. 8 factorial into 8 factorial. I am applying the formula. 8 minus 1 will be 7 factorial into 7 factorial into 6 factorial. Okay. Now you see here 8 factorial gone, 7 factorial gone. Okay. Now this one I can make it into 8 factorial. 9 into 8 factorial by 8 factorial into 9 and 6 factorial is left. 9 into 8 into 7 into 6 factorial. 6 factorial. Okay. Cross. So this 8 cancelled. So 9 into 9 into 8 into 7, which will again give you 4, 5, 3, 6. Same answer. Okay. Same answer. same answer you will get. It is better to do it this way. Consider all the 3 and then put R, like question number 1. Okay. So I hope this one is clear to you. Now question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Okay, now for explanation purpose, 3-digit, no? So I will make 3 boxes. Okay, 1, 2, 3 boxes. And the numbers are 1, 2, 3, 4, 6, 7. Now, we have to make 3-digit even numbers. Now, for the even numbers, I have told you that only in the one place must be always end with an even number. And from here, even number are 2, 4 and 6. Okay. That means you have 3 ways here. Okay. Wherever condition is required, you are going to check for that portion first. Okay. So since here we have problem with the one place. So we need 3. Okay, it can be filled with 3. The numbers are 2, 4 and 6. So we have 3 numbers here. And here digit is not repeated. Okay. Suppose among these 2, 4, 6, I have used 2. Okay. I have used 2. Then for the next one, I will be left with how many? 1, 2, 3, 4, 5. I will be left with 5. Say for the first place, I will be left with 5 options. Okay. And for the next, or again, repeat digit cannot be repeated. So for 5, then 1 will be reduced again, isn't it? If among these numbers I have taken 3, then I will be left with, see, 2. Say suppose I have taken 1. 2, 4, 6 is booked. Okay. 6 and 1 I have taken here and 2 is there. So I will be left with 1 and 2 is taken. I will be left with 4 numbers, 3, 4, 6 and 7 here. So I will be left with 4 numbers. Okay. So by principle of fundamental counting, how you do is 5 into 4 into 3. Okay. 60. Now using permutation formula. Okay. How you can do? Always consider from the one which have conditions. Here in the one place I have 3 options, 3 objects, that is 2, 4 and 6. So my n will be 3 in this case, and I'm considering for the one box, that is the one place. My arrangement will be 1, that is 3p1. Okay. If suppose out of these 3 I have taken one number, then I will be left with 5 numbers out of 6. If I have taken one even number here, then I will be left with 5 numbers only. So for these 2, what I can write is 5, then my arrangement is 2. Okay. So total will be, total 3-digit, you will write it in a proper way. I'm writing it in short. Okay, total 3-digit even numbers will be 5p2 into 3p1. Multiply. Okay, multiply it. This is for this 2 is 5p2 and for the last is 3p1. So 5 factorial by 5 minus 2 I will get 3 factorial into 3 factorial. 3 minus 1 I will get 2 factorial. 5 into 4 into 3 into 2 factorial I can express, and down I have 2 factorial, 2 and 2 cut, answer is 60. This is using my permutation formula, and this one is using principle of fundamental counting. Okay, any one answer will be same. Whenever condition repetition not allowed is given, then I can use the same question with permutation formula. Okay, so I hope this one is clear to you. Very easy. You did not need to write 2, but instead you write using the permutation formula. Okay. Now next is question number 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. How many of these will be even? So for now, this is the second part of the question, okay? The first part, what we have to find is find the number of 4-digit numbers that can be formed using this digit when no digit is repeated. So again, make 4 boxes for better understanding. Okay. Forget about even now. You have digit 1, 2, 3, 4, 5. Okay. Using these numbers, how many 4 digits can be formed? Okay. So here total number of objects will be that is your n is here. How many digits are there? There is no condition in the first part, nothing. So I have simple 5 digits. Okay, 5 numbers. And what are the arrangement? Find the number of 4 digits. My arrangement will be 4 here. Okay. For the first part, there is no condition. We are not considering the condition. Okay. So it is very easy now. NPR is your formula. Put 5P4. Now solve 5 factorial. 5 minus 4 factorial. That is 5 factorial divided by 1 factorial. 1 factorial is 1 only. Okay. Remember, 1 factorial is 1 only. That is 1 into 1. I will get 1. So 5 factorial. Solve 5 factorial. 5 into 4 into 3 into 1. Okay. This is my 5 factorial. 120 is my answer for the first part. That is 124 digit numbers can be formed using this digit when repetition is not allowed. Now we will come to the second part. How many of this will be even? Okay. First part is done. Now we will check how many of this will be even. Okay. Numbers are 1, 2, 3, 4 and 5. These are the numbers, and from here we have to choose which one is the even. Only 2 and 4 is your even number. Okay, that means we have to construct a 4-digit number, 4-digit even number. Okay, so even number means one place must be ended with the even numbers. So I have how many numbers? 2 numbers only. So I have 2 numbers, that is 2 and 4. Okay, now digits cannot be repeated. If suppose constructing the first 4 digit, if suppose I have taken for one number 2, even number, okay, 2, then I will be left with 2 is taken, then I will be left with 4 numbers only. So here I will have 4 ways. Okay, and again 1 will be reducing because digits cannot be repeated. If digit is repeated in 4, then 4 will be coming here also. Okay, instead all numbers will be coming. So 4, then here will be 3, here will be 2. So using principle of fundamental counting, your total 4 digits will be, how you used to do is like this: 4 into 3 into 2 into 2, 12 into 4, 48. 48 even numbers will be coming. Now using what? Permutation. How you can solve? Okay, same like previous question. Here I have 2 options left, that is 2 and 4, for making a digit 4-digit even number. That means my n is going to be 2 and condition is coming for the 1th place only. So arrangement will be 1. So it will be 2p1. And for the remaining 3 boxes, if I have taken out of 2 and 4, I have taken 1 number, then I will be left with 4 numbers for filling up these 3 boxes. So for this total 3, 4p, how many boxes? 3. Okay, my total will be, total 4-digit will be 4-digit even number will be multiply 4p3 into 2p1. 4 factorial, 4 minus 3 will give us 1 factorial, so I will not write, into 2 factorial. 4 into 3 into 2, 2 factorial you break, 2 into 1, okay, 12 into 4, answer you will get same only, that is 48, using the permutation formula. Okay, so I hope this one is clear to you.